Hi everyone. Today we'll be presenting our Data Plus program project called Predicting Student Decisions. My name is Edward and I am joined by Malia, Alina, and Abdul. Our goal was to develop tools to help officers at Duke involved in admissions, such as the Office of Undergraduate Admissions and the Office of Student Affairs, better understand admitted student profiles and create data-driven models that predict which admitted students will choose to enroll. This is incredibly important for university planning, from housing and financial aid to course and class size allocation, but also for the general reputation of the school. While Duke already uses yield models, we wanted to improve prediction accuracy by using two different machine learning techniques and a more expansive set of features, along with creating dashboards and applications for admissions workers to be able to utilize. We analyzed 3 years of admissions data and incorporated both traditional and less visible variables. We were especially interested in identifying patterns across different student groups, with the goal of better understanding and supporting student successes. We also reviewed research literature to better understand what factors influence yield in higher education and how our work could contribute to institutional strategy.
Once we gathered the admissions data, we did extensive data wrangling that included handling missing values, normalizing features, and encoding categorical data into usable formats. This enabled us to build a clean dataset that was more consistent for all 3 years. We then explored how yield rates varied across different factors, including major, income level, geographic region, and first generation status. These patterns revealed notable differences in matriculation behavior across different student subgroups, highlighting areas where yield is consistently higher or lower. We focused on three key types of predictors: demographics, like gender and location, financial aid, such as net cost and scholarships, engagement and outreach factors, such as Blue Devil Days. For modeling, we trained both logistic regression and random forests, each split into an all samples group and a regular decision only group. Logistic regression gave us more interpretability, while the random forest model was better at picking up complex nonlinear patterns. The early decision logistic model performed especially well in terms of accuracy and precision. Regular decision was more difficult to predict, likely because those applicants are less committed and more variable in behavior. The random forest models improved overall accuracy, but the challenge of predicting regular decision outcomes remained, pointing to broader uncertainty in that group.
We built two interactive tools to visualize our findings. Firstly, we built a Streamlit app, which lets users simulate different student profiles, for example, with varying income, major, or aid level, and see predicted yield outcomes in real time. This allows admissions officers to explore what-if scenarios. For instance, how would changing a financial aid offer affect a student's decision to enroll? The second tool was a Tableau dashboard. This let us dive into broader trends, comparing how yield rates vary by test scores, majors, and student background. For example, one insight we saw was that standardized test scores had a stronger influence in some majors than others. We also noticed how different applicant groups, such as first generation or low income students, responded differently to financial aid. These two tools help admissions teams visualize, better interpret, and act on our model results quickly and intuitively.
To conclude, this project laid the roadmap to support smarter enrollment strategies in higher education. By using predictive models alongside with interactive dashboard, we gained a deeper understanding of the many factors that influence whether a student decides to enroll, from financial aid and location to academic interest and institutional reputation. One of our biggest key takeaways was just how complex these decisions can be, especially for regular decision applicants, where many variables overlap and interact. Our model helped uncover patterns that aren't always visible on the surface. We hope our work contributes to efforts at Duke to better serve students, particularly those from underrepresented and underserved backgrounds, and to make the admissions process more informed and equitable. Lastly, we are incredibly grateful to Diego Rodriguez and Heather Magler for their support and mentorship throughout this project. Their guidance was essential every step of the way. Thank you.